but I think maybe we can start. Okay, so for the ones joining this breakout for the first time, we had a breakout last week where we started to present half of the repricing EIPs, and now we are going to discuss the other half. I shared the agenda on Discord, but anyways, I just wanted to give you a quick overview of what we are going to discuss. So we will start by, so we'll dive right in the deep dives for each reprice. And I will give 5 minutes to each presenter. So I will try to, if the discussion is taking too long, I will interrupt and move to the next so that we have enough time to discuss all the EIPs. And at the end, we'll do a wrap up and some final comments on the whole, as a summary of the two breakout calls. And we should have then also some more time for more general comments from your side. And we will start now with 7904, so the general compute repricing, and I will be presenting this one. So this EIP, what is the motivation? So essentially, based on our current benchmarks, we know that the compute operations don't have harmonized costs. So we have some operations that are overpriced. So this means that because they are too expensive, we are actually limiting the throughput that these operations could have. And on the other hand, we have other operations that are underpriced. So this means that they are too cheap. And because of this, they create a bottleneck. So we cannot continue to increase the gas limit without making these operations more expensive. And to illustrate a little bit this point, so on the side of the overpriced operations, so the ones where we could be processing more of these operations per block, but because their gas price is too expensive, they are sort of limited by the current gas limits. And here I have some recent plots that show the so I computed this metric that I call efficiency loss. So essentially is based on the benchmarks from YASEC, which was the data that started this EIP. We can see how much each operation takes in nanoseconds to execute. And we can compute on this case of a 4-second execution time. So I'm assuming we have EPBS. How many operations we could fit within those 4 seconds, theoretically, based on these benchmarks. And also we can compute what are the maximum operations that the given gas price gives. So at current price, and the gas limit of 300 million gas, we can compute how many of these operations, assuming we don't have any of the other opcodes there, which is impossible, but it's a simplified calculation. We can say what is the maximum operations we could fit within that gas limit and for a certain price. And then we compute the difference. So what I'm doing here is like, for instance, for the current price on the block on top, we are seeing each point here on this distribution is a single opcode. So we can say it's, so for instance, for some opcodes, their efficiency loss is 10. So this means that we could have 10 times more of these opcodes with so with the theoretical, we could have 10 times more, but we are being limited by the current price. And then I also show here two optional prices. So I'm doing a price where I'm anchoring on this gas limit for 4 seconds, but I'm not doing fractional gas, so I'm just rounding things to the closest unit. And then with fractional gas is the third one. And so you can see like the level of efficiency losses per opcode that we get under these 3 scenarios. And the plot down is, instead of looking at specific opcodes, we are looking at transactions. So I did a sample of transactions, check their traces, see what opcodes are there, and then I compute these things based on the costs of the opcode and the benchmark values. And here we see that the efficiency loss per transaction is much lower than per opcode. And the reason is that a lot of gas on transaction is also used for state operations instead of pure compute. And for those, I'm assuming that they are fully efficient because I don't have the data. And so this is also bringing some bias. But essentially, we also know that compute as a size of gas used is relatively small when compared with other resources like state creation and state access and so on and so forth. And so also the impact on transaction level is also limited. But so this gives you kind of a sense of the numbers. And for the underprice, the best data we have to assess this is the gas benchmarks that are is a joint collaboration between the EF and Nethermind team. And essentially they are trying to build these worst case blocks or these worst case scenarios and benchmarking them. And essentially, if we were to target this 300 million gas limit at 4 seconds, then we could see that any opcode that is performing at less than 75 million gas per second would be a bottleneck. So it should become more expensive. And some of the examples would be the precompiles, Ketchak, and some of the mod operations. Okay, so what is the proposal? So essentially, the idea here is we will benchmark all operations and collect their execution time. Then we need to pick a target for the repricing, which we call the anchor. And essentially here, we essentially need to say, come Amsterdam, how does the block limit look like? So what block limit are we targeting? And also what window for the execution time do we get from EPPS? And with these 2 things, then we can set this target for repricing and then change the operations prices accordingly. And I want to highlight that the current EIP number, so the numbers you see in the EIP, so the actual repricing numbers there, they are not final. And the reason is that we are still improving on benchmarks. So we had a few opcodes that are out. The precompiles are not included at the moment, and we really want to include them. And also we need to reconsider the anchor. So essentially we need to figure out what gas limit we should be targeting for Amsterdam and what the time for execution should we consider. And I also wanted to say that we have some flavors that we can do with this EIP. So one way is we can go with the minimum repricing. And here we essentially will be only repricing the underprice operation. So we would only make the bottlenecks more expensive and leave everything out. What this would mean is that we remove the bottleneck, so we could scale to our target gas limit, but we wouldn't fix the efficiency losses from the cheaper opcodes. So those will still be, so we'll still be losing some scalability on those specific opcodes. The second option is we reprice all operations, so both the underpriced and the overpriced, but we ignore the rounding error. So we don't do anything about, so if an opcode should be 0.1, we just assume it is 1. So we are not changing anything on the internals of gas metering. And the more disruptive change is we reprice all operations and we fix the rounding errors, either with 8053 or 8059. And the trade-off here is, on one hand, the more you change, the more efficiency gains you get, but it comes at the cost of fork complexity. So there's a trade-off here, and I think it's something we need to, once we have the final benchmark numbers, it's something we need to consider. And I know I'm a bit 2 minutes out, so I will skip the comments, but if you want to add anything, please just use the chat and I'll try to reply. And I think now we'll move to the next presenter, which is Tony. Is presenting block house accounting without refunds. Tony, when you want, you can start.
Yeah, can you hear me?
Yes, we can hear you.
Perfect. Yeah, I haven't prepared a presentation or anything, but this is regarding ERP 7778, and it's a rather simple change. What we would do is, instead of subtracting the refunds before we apply the gas used to the gas available in the block, we would just not do that. So basically, when we count the gas used against the block gas limit, refunds would not count towards it. And the rationale is that today, for example, the worst case block when it comes to state churn, so how much state can be updated or changed within a single block, this originates from this refund pricing, because with those 25% refunds, you can get some extra gas out of the block that you can then use for other transactions. And in the end, you can cycle through and get 25% more gas into a block. So this is a rather small change that should be quite manageable. Yeah, I'm happy to receive any feedback or comments regarding the ERP. But that's essentially all I have to say about it.
Yes, I would say we still have lots of time, so yeah, we have time for discussion.
Yeah, I mean, just to briefly say, I feel like this ERP, from everyone I talked to so far, seems to be the one out of all the repricings to be the most universally kind of supported one. So it seems to me like, I mean, we can discuss it a bit more, but it seems to me like this one I kind of trust will be in the fork. So I think
which one?
it's
the
great.
refunds?
Yeah. I mean, maybe I'm wrong, actually. Like, if you disagree with the statement, all the better. Then
I totally
very
agree.
curious to hear from. Yeah.
I totally agree. This seems like an oversight in the gas accounting stuff to begin with, like protocol oversight.
Yep. So I mean, I guess coming out of the breakouts for like tomorrow's ACD, it feels like that's the one takeaway. Like, this one ERP seems to just have pretty universal support. So that's already one good takeaway.
I have a question for the general repricing EIP. So let's say we tune in numbers for Glamsterdam and we do like repricing of all opcodes and all precompiles, and we target 300 megagas in Glamsterdam. Two questions. One, what if we want to then target 600 megagas? Then the opcodes would get potentially underpriced. That's one thing. Though with parallel execution, maybe we can work around this with like increasing the CPU and hardware spec, etc. So that's one thing. And the other thing, what about ZKVMs? If we actually reduce some pricing of some opcodes, maybe we'll have to increase them in a year or something. So it seems somewhat counterproductive to do that. without numbers from ZK VMs. So those are my two questions.
Right. So I will try to give an answer to both, and then if more people have further comments, please add them. So on the first question, I would say this reprice will give us a one-time boost. So we are fixing these pricing bugs, and it will give us a one-time boost in scalability. So it will allow us to increase the gas limit to the limit we'll be setting there. Then for further gas limits, essentially we would have to take optimizations and hardware improvements, and those will not give you like the same level of boost you can have with repricing, because this is just a one-time thing. But I would expect that, again, as clients optimize and hardware improves, we should be able to continue to scale, even though not at the same level. So I think it's important. That's why the question of what limit do we want to target is also important here. On the ZK VMs, I would expect that once we have the fork where we introduce ZK VM, we should do a reprice then. I don't think it makes sense to do it now because we don't yet have ready numbers. Then you could ask, like, why are we doing this overhead if we are going to do another reprice once we have ZK VMs? And my argument there, I think, is like, we still don't know, like, ZK VMs are not a short time thing, and these are clear short-term gains that we can get now. And so I think it's worth the work that we are putting it for us to be able to have these gains now rather than once ZK VM arrives. Yeah, I don't know, Sophia and Andrew, if you want to comment on this or if your hand is up for a different question.
Yeah, so I'll reiterate. I feel like I say this like at least once a week. So our plan to roll out ZK EVMs is to have first an optional tester client, and we're planning to ship that at basically right after Glamsterdam goes live, because we need the extra proving time from EPBS to do that. So there won't be like a ZK EVM fork. With regards to ZK repricing, I think that this is not like an outlier view now amongst my team working on this, and this is what Vitalik proposed this week, that a better approach than ZK-related repricing is to just eliminate all precompiles and replace them with the EVM code, which will, of course, be like much more expensive. This will also will greatly increase security and really help us scale traditionally. If you look at what the bottlenecks have been, just scaling right now in terms of edge cases from different clients having different implementations of these. And I think that we don't have like a obvious candidate for like an H-star EL headliner. We kind of do for the CL. Given what's involved in the migration of this, I think that would be a great thing to do then. So that's my current view on that. But also right now, I think that it's reasonable to say maybe we shouldn't make any precompiles cheaper in Glamsterdam.
Okay. Okay, so I think, conscious of time, I think we'll need to move to the next presentation. I'm sorry, Andrew, Ansgar, and Lukasz. I will ask you to just comment in the chat. And the next presenter is Carl. So he's going to present linear EVM memory limits, which is EIP 7686. Carl, are you there? Can you present?
Yeah, absolutely. Sorry, 1 second. Two things. So this came out of, I built a spreadsheet that I shared in the chat, just tracking where each opcode and recompile and everything, like transactions, are repriced within all the repricing EIPs. And what I wasn't particularly happy with was things for memory and memory expansion. there already is an EIP proposed, which is this page-based linear memory costing, but it ends up being quite complicated and quite opinionated on exactly how things work with pages and it's like architecture decisions, which might not necessarily be native to the underlying architecture and might not be available to whatever VM you're using. So I'm PFIing EIP 7686, which is just very simple linear EVM memory limits. Basically, the idea is currently there's this quadratic factor as you expand memory, which makes it rather expensive, arguably unnecessarily so, given how much memory is available on your computer. So the idea here is that we can make things a lot cheaper and a lot simpler by just having a linear memory model. And it's also not as though the resource consumption on your own node will go up quadratically as you expand the memory. So effectively, this has two components to it. One is instead of this old complicated quadratic system, it switches to this very simple, your memory cost is just linear in the memory you're using. And then the second thing is it changes the way we calculate the max gas available for a call. So instead of this 63/64 of the remaining gas or whatever, it changes it to, this looks complicated, but basically the amount of gas remaining for the call. And so this means that at the start of a transaction, you can allocate all the memory that you could ever need for this transaction. Then at each call, you can sort of subdivide the remaining memory into what you need. So it both linearizes the cost of memory and simplifies the way we reason about memory. Any questions?
Yeah, maybe because this linear memory, this change to linear memory, that seems logical, but I'm not really understanding why this max call gas is introduced. But maybe that's more specification. Maybe that's first more.
Yeah. So the problem is that you need some kind of limit. The previous way we were limiting the maximum amount of memory available was just the fact that the quadratic cost of memory just blows up in your face, and then it becomes very expensive to access crazy amounts of memory. The idea here is to you have to go into the EIP for the details, or we can chat async. But the idea here is that we can have limits that are more concrete, just as a function of the amount of compute that you can physically do.
Yes.
This for every possible call.
Yes, this actually makes a lot of sense, because I forgot that we can create call frames, so you can actually, yeah, okay, you have more call frames. Yeah, okay, makes sense. Thank you.
So we analyzed this EAP and also a competing somewhat EAP, which is 7923 linear page-based memory. And yeah, to be honest, I think that the page-based gives us more gives especially the compilers more flexibility. So both are fine in terms of repricing, but that one is a bit more interesting in terms of other considerations. That's our input.
Yeah, you can design architectures around the paging, which you could make some slightly more efficient choices for certain compilers. If that's the direction we want to go to, we can. It's just it is a lot more complicated in my opinion. And the idea here is just, what if we had a more simple offering? And I think you could basically get most of those same gains in this alternative model, because I think most of the gains there come by assuming you allocate a whole page, and then in this model, you can just allocate to the equivalent of what would be a page and pay the same amounts. Right, client.
Yes, we
Yeah,
still have some
just
time, so
curious
let's go.
about to hear more from Lukash about why you like paging more. I think if I remember correctly, the page size is 4096 bytes for that EIP, which is already far more than 99.9% of transactions actually use. So it feels a little bit like they add a ton of machinery to support these pages. when
You can
they'll
you can like separate stack and heap because you can with linear
stack and what?
heap
Say that again?
you can
Oh,
do
stack and heap,
like yeah. So you can have like you can allocate something two pieces of memory far away from each other, which you can't do
Why?
linear.
Why is that different with the page based? Like you will still have to pay like pretty similar cost for the amount of memory you're allocating. No?
No,
You don't
what?
you don't pay between the two. With a linear model, you pay for all of the memory, whereas with the page base, you could
You pay for the whole
allocate.
page.
Yes, but you don't pay for the memory between the pages.
What's the memory between the pages?
So if
You
I
can
wanted to allocate a stack at the bottom that I'm going to use as a stack part of memory, and I want to
Mhm.
allocate a heap at a really far away from that, so
Mhm.
they grow towards each other. I'm not paying for the memory in the middle. Whereas if it's a linear model, you have to pay that memory between the two is considered used, and you have to pay for it.
Yeah. I mean, if we're okay with them not paying for that memory in the page-based system, that would mean that our linear pricing is just not that reflective of the true cost, because that memory is allocated for a page
So
by the VM.
it basically allows of more dynamic address space using virtual addressing, right? So basically what your OS does and charges you for actually used memory. I agree that maybe the page size is too big. Maybe that's the case, right? So maybe we need
Yeah.
to tweak that. That's I think that's a just starting point here. And if we like know that the page size is too big, that's something different, and we can tweak it very easily. Just decrease the page size. I think it was more of a hardware thing that they went with 4K because
Mhm.
4K is what more hardware is using, right? And potentially even I'm not sure if I understand how this would work, like direct hardware mapping of memory there in that EAP. So like using hardware more on the bare metal there in terms of like memory layout. But yeah, that basically you can allocate things far away from each other in virtual address space while still using very small amount of memory. So if they grow, they have a space to grow in the address space.
Yeah. Is this
Sorry, guys. I know that we are already discussing an EIP that we haven't presented yet, so I think it would be helpful if we can have Charles, which is the next presenter, talk about the EIP first, and then we can continue the discussion. Charles, are you okay to
Yes.
present?
Hello. Let me share my screen. So I did look at EIP 7686, and the reason, just to follow up on everything that was being discussed, the reason I chose to draft this page-based thing is because, as Lucas pointed out, if you have linear memory, first of all, you can't really predict where the end of memory is. The way that 7686 sets it up, you're basically constrained by whatever the parent call did. But as a compiler, which I'm most familiar with, but also like as a user in general, like you want the ability to allocate memory that's very far away from each other. The classic example is stack versus heap. So stack grows from the top of memory. You just start from like the top of memory, which in 7923 is pinned at 2 to the 32 bytes, and you start the heap from 0. So you are basically guaranteed that these are never going to collide. It's a very useful abstraction, where if you only have a small amount of memory to work with, and you especially don't know where the end of memory is going to be, then you can only grow in one direction, and that leads to things like in Solidity, where they only have memory which grows in one direction. What kind of data do you want to put on the heap versus memory stack for smart contracts? Well, first of all, we would have like a regular programming language that works like a programming language from the 2020s, not the 1980s. And all modern languages have a heap and stack separation. Is this
But the
less
environment
relevant?
is pretty different.
By stack, I'm referring to the call stack, not the operand stack.
Oh, I see. Okay.
Yeah. Sorry. In the future, in this case, stack is always. I'm always talking about the call stack. So like function frames can grow in a separate place from data. Are there any more questions about that? I can go into the details of the EIP. So I did some benchmarks on kind of a random computer, but maybe representative. And you see that there's this big, so obviously it's most expensive to allocate a fresh page. It's kind of, and then there's this kind of threshold around 32 megabytes, which is the size of the L1 cache. Sorry, one of the caches, I guess L3, where memory access gets random memory access gets a lot more expensive. There's kind of two ways to address this. What if we give it a call frame on free page and grow from there? I'll respond to that later. So there's kind of two ways to address this kind of drop off in performance after 32 megabytes. One is to just limit the amount of memory that every EVM call frame has to 32 megabytes. That's actually totally reasonable and something I'm willing to consider. The way I designed it here is there's an LRU cache, which tracks the most recently used touch pages, which I've gotten feedback from a lot of people that it seems located. But I added in this draft because it's really only a couple lines and a single data structure. But that's kind of like on the table for cutting out of the AIP. What else did I want to discuss here? I think that's the main thing, is whether to use this LRU cache or just simply limit the amount of data that a call frame can use, megabytes, and consider increasing that in the future. There's lots of things you can do with virtual memory. For example, having hash tables in memory, being able to allocate stuff on the heap and stuff like this. And there's a lot of things that people would like to do with smart contracts that they can't do in EVM, in Viper or Solidity, because a very common use case is in-memory hash maps. And it's because we don't have stack heap separation. There's things that the compiler can do to work around this, but it's just not very natural. And like I stated at the beginning, only having not having virtual memory is a restriction from like the 1980s. L3 cache will be contended between multiple transactions in parallel after BLS. Yes, that's true. But I think the 32 megabytes is usually kind of, I should double check on this. 4096 bytes was used because it's just a very common page size on machines. It's the size of the Linux page, and it could also be like 512 bytes. This whole page. Oh, another thing is implementation complexity. There's really a very simple and I would say elegant implementation for this, which is that you just mmap the whole thing, the entire 32 bytes. Then you let the operating system take care of the memory allocation. And I'm pretty sure this works on all modern systems. I don't know what the page sizes are on Raspberry Pi or whatever, but I'm sure we can tune it so that it will work on those. My co-author, Joe Qi, also wrote an implementation which doesn't even require this data structure for bookkeeping which pages are allocated. It just uses the operating system's built-in page allocator and detects when there's a fault to detect if you need to charge the 100 gas or not. So the implementation is really a lot simpler than it looks. And
Charles, sorry to interrupt, but conscious
yes.
of time, we really need to move to the next presentation. So I will ask for people to ask questions in the chat, and we will move to the next presentation, which is the hard limits for transient storage, which I will, Charles, if you can stop sharing so I can share mine. Thank you. So I'll quickly go through it. So this is an EIP that Charles initially started, and then I came and I'm supporting as well. But essentially the motivation is the transient storage operations. They currently cost the same as a warm storage access. Even though transient storage is significantly lighter on EVM resources. And the consequence of this is that this high cost incentivizes the use of these operations. On one hand, we don't see devs using more of these, and instead they tend to use state operations and then leaning on state refunds for not spending as much gas. And also the implementation of reentrancy logs by default is still expensive. And so this sort of discourages a more wide adoption of these safeguards. And the proposal is simple. So the idea is to decrease T-load cost to 5, T-store cost to 12, and then limiting the max number of slots per transaction to prevent those attacks. And essentially for this to work, we need to implement a new counter per transaction where we track the number of slots allocated. There's an alternative design where instead of having a hard limit, we will just increase the price of further slot allocations after the max limit. So there's still this optional design. I would reiterate that I think we still need to benchmark these costs. So these are still values that I personally see as work in progress. So we still need to make sure they are consistent with the rest of the compute repricings. And on that, I think we still have some time for comments. I couldn't see the chat, so if there are...
Yeah, I have a comment.
Yeah.
Because with my napkin math, it might be off, with this limit, a transaction that is 16 million gas can still allocate 1.6 gigabyte through T-Store only. And without this API, actually, now I think it can even allocate more, but I'm like not sure if I calculate that correctly. So both are kind of probably unacceptable, especially with balls when we can have 8 of those transactions executing in parallel. Then we allocate 12 gigabytes on T-Store as a like worst case scenario, which is like potential DOS attack, maybe. I don't know.
Right.
Sounds
So
bad.
Yeah, so I think this is one of those where the parameters need to also be benchmarked. So I think the fact that we are introducing a limit on the number of slots should help there. It's just a question of what should that limit be. And yeah, I agree that we still need to think a bit more carefully and benchmark
I
it.
think it should be in megabytes and like tens of megabytes, not hundreds or thousands of megabytes.
Okay. Any more comments? We still have 1 minute. If not, I will move to the next presentation.
I have one.
There's a
Um,
yeah, you can go.
I don't get while it said that T-load is different than S-load warm cost. In our EVM implementation, it is one hash map get. So those two should be very similar, to not say the same.
Mm-hmm. So I think,
That's my comment.
okay, yeah, I think this is something we should be able to see in the benchmarks, right? So I think that's why it's important that we do them. And conscious of time, we'll move to the next. So if you have any other comments, please use the chat. And next we have Tony is going to present two EIPs. So first the increase call data floor costs, and then increase access list costs. Tony, I will give the floor to you.
Perfect, thank you. So let me start with 7976. That's the call data floor one. And the rationale is quite simple. With Amsterdam, block size will increase because of block level access lists, and also increasing gas limits will contribute to bigger worst case blocks. And we already had in Pectra 7623, which introduced this floor mechanism where essentially 99% of the transactions are unaffected, while a few call data heavy transactions pay more per byte of call data. And the proposal here is to increase the gas cost per byte for those affected users by 33%. So essentially, we reduce the worst case block size by the same amount by 33%. And instead of paying 10 bytes for a 0 byte and 10 gas for a 0 byte and 40 gas for a non-zero byte, they would spend 15 and 60 gas. So it would go from 10 to 15 and from 40 to 60. I have done an analysis on the EAP. Let me post this in the chat. Or maybe Maria, I've sent it to you. Maybe you can post it into the chat in the meantime. And yeah, the goal is just to reduce the worst case block size. And it's a rather simple mechanism because everything is already in place and it's just a change in constant. Then going on to the next one, which is 7981, which reprices access lists. And this is a rather interesting topic because after we shipped 7623, the worst case block size didn't consist only of call data anymore, but essentially you would use 2/3 of your gas that is available for access list entries and the rest for call data. And this is because in this case, you still pay the lower price for the call data, and at the same time, you would not pay anything for the data in the access list. And what 7981 does is putting the same price that we put on call data, putting that on access lists. It adds a price on access lists, which also makes them unfeasible, at least economically. So it can be seen as deprecating them. And the impact is quite big. So by shipping that, we reduce the block size by 21%. And I guess very, very few users that are impacted by this one. Yeah, that's essentially all I have. Happy to hear thoughts.
Go, Ben.
Yeah, I think this is quite good because it maintains the original reason for introducing access lists, which was for the repricing, which broke some contracts. But also, there was a suggestion we could use access lists for parallelization, which never really emerged due to the pricing being off. But that's now solved by valves, so we don't need them for that purpose. So I think it makes a lot of sense.
Okay. If there are no more comments, I think now, Ansgar, do you want to do the wrap up?
Sure, yeah. I mean, I prepared one slide just because I usually think it's actually nicer to look at something rather than just me talking. So, one sec. Can you see my screen?
I can see it. Yes.
Perfect. Yeah, I mean, this is just my take as a summary, and I also just wanted to briefly go over this and then just actually have at least a few minutes of discussion here. And again, just my take. I personally really just wanted to reiterate that there's really these two different types of repricing ERPs that we discussed. There's the core of repricings, which is just about the EVM as it functions today. Just make sure that all the operations have the same kind of cost per second, basically, of operation that they take. Those really, to me, have the highest promise, the highest potential impact. But I also think, and that's something that for me really came out of this last week or last 2 weeks of people kind of starting to take a closer look, that really both in terms of just the exact current shape with kind of it being spread across multiple EAPs is something we could revisit. But also people are very concerned about like, hey, is it realistic that we can benchmark all of these things in time for Amsterdam, right? I saw this in chat today. I'm hearing this quite a bit. I think for one, I do think it's worth embracing. I think if we really make this a core priority for the EL for Amsterdam, I think we can get a lot done here. Also, a lot of the preparatory work has been done now with just like setting up the benchmarking harnesses, this kind of stuff. So I do think it's now a more feasible general exercise. That all said, I do still think that it's worth, even within that kind of core group, to explore maybe taking some sort of 80-20 approach where we try to just like identify just like which operations, maybe if we don't reprice everything, but we say, look, kind of this middle band of operations that are reasonably priced, we just leave alone for now. We revisit maybe an H-star or something, and we only reprice the things that are way too cheap. So like all of the precompiles, whatever, but also say on the state side, the data side, whatever, basically just only reprice the things that really need to be repriced to not block us. And then maybe consider repricing a few of the things that are way too expensive so that they're so inefficient that maybe we can make them a bit cheaper or something, but really kind of not have this ambition of repricing everything at once. I'm open to that personally. But yeah, overall the through line here needs to be that like, if unless we completely reject this part of repricing from Amsterdam, the focus of the next months, they need to be on benchmarking. And on the F side, we're getting ready to support this as much as possible. And then further points I just wanted to make is I would think it's just important to stress again, like repricings really need to also take EPBS and block levels list into account. That has only that has not been front and center so far because these were also moving targets. But I think again, these core repricings play a pretty crucial role in unblocking the potential there, especially block levels list. In EPBS, it's only an optimization because it's necessary to take advantage of the fact that you can keep executing after the PTC deadline. But for block levels lists, really, because block levels lists don't help with data. So unless you make everything else relatively cheaper compared to data, then block levels lists just don't help. So basically, you kind of need some sort of repricings, at least making data more expensive, right? The minimal version of it would be not reprice everything, just reprice data. But either way, basically, like you need some sort of repricing, otherwise block levels lists on their own are kind of useless. And then one more really important point I want to stress. I know the specific way in which state growth is proposed to be addressed here in the repricings is somewhat contentious, but I just wanted to say, like, I think we don't really have a choice unless we're willing to accept a state growth rate that's up to, say, 10 times, 5, 6, 7, 10 times higher than it was at the beginning of the year when we were at 30 million. Because even like pre-Amsterdam, we might get to, say, 100 million, and then EPBS gives us double the slot span. Block levels list with the parallelizations, the refund mechanism, like all of this could easily get us on its own already to 200 plus million. That's even before any of the core repricings. So if we go to 200-300 million gas, like I don't think we can just leave state growth at the current prices and just accept a 10 times higher growth rate. I think we need to do something anyway in Amsterdam. But maybe this is worth reconsidering alternative approaches, right? Lucas had a proposal that I thought was quite interesting to basically like just scale the price with the gas limit, and then also Anders, that one missed the proposal that time, but I think under exceptional circumstances, we could consider it even for Glamsterdam already, which reconsiders adding a fee dimension while trying to keep the complexity as minimum as possible. Again, I think we kind of need to do something about state growth at least. And then last point, just keep in mind, I don't think I need to tell you that. I think everyone's aware. We have a lot of ERPs for Glamsterdam. So my feeling is, especially if we indeed go ahead with the core repricings, which is my recommendation, there really is a very limited budget here. So I think basically realistically from the repricing side, it's probably only possible to do core repricings plus a very small number of additions. So maybe the refund EIP and then maybe, I don't know, 1, 2, 3 of the others. But we would probably have to reject the majority now and revisit them for HSTAR. So that's my summary. And yeah, I'd be really curious to get people's takes. And Ben, I think you were first.
Yeah, and just on state growth, you might also want to consider it as to what's the state growth between Glamsterdam and HSTAR. Because I assume, if we didn't do anything in Glamsterdam, we'd see the effect of all this repricing, and then we definitely do something in HSTAR. So it's not necessarily what's the state growth for all time.
Yeah, I think that's fair. I think we could, especially because we would say even with these like gas limit increases from the benefits we get from Amsterdam, we wouldn't like ramp it up right after the fork, right? So it might take a few months afterwards anyway. So maybe would actually be a period of just a few months. I still am personally very hesitant to just leave it until HSTAR, but okay, maybe it's not as impossible as I made it sound. Good point. Lukasz?
So 2 comments from me. One, that in my opinion, repricings need to take the ZK VMs into account. Maybe, we don't have very precise numbers from them, etc., but we need to at least validate that we are not doing something that we will be retracting very soon. Like especially if we are like lowering some gas costs, that we want to be increasing them very shortly. So that needs to be taken into account. And state growth, yeah, we probably need to do something. Like my approach is, I don't know, I don't like it even that much, but I liked it a bit better than the original one, which was just fixed, because I don't think we'll jump directly to 300 megagas, or maybe you can correct me if I'm wrong. Maybe we will be just jumping to 300 megagas directly, and then that's also fine. Ben also pointed out that with increasing some of those internally, that we are basically pricing new users very high compared to the old users, which is somewhat not fair for them in some way. So just leaving that here.
Yeah, good comments. I won't respond just because of time. Andrew?
Yeah, so on state growth, I wanted to say that we can mitigate it to some extent with repricing, but I think strategically we have to address it with a state expiry, either at the partial state expiry. I think Guillaume had some ideas for Verco. Maybe they can be done in the binary tree context, and or full state expiry. I think that required address expansion and stalled at that, but maybe with renewed focus we will find a solution. But basically I think yeah, that would be a proper solution to state growth.
Yeah, quick comment there from my side. I would just say, like, my feeling has been, and that's also what I want on the EF side and on the research, but I think we should do this obviously ecosystem-wide, like quarter-wide. My feeling is by HSTAR, I want to have a really good understanding of what is our strategy around state growth. I'm not convinced that we need to do something like state expiry. I would say probably yes, but I'm not like certain yet, because I think ZK EVM will change the environment enough. Like many nodes can just be stateless, that maybe it's okay to just accept that the state will just grow a lot, and we're fine with that because only more specialized nodes require the state. But of course, still, builders need the state, RPC providers need the state, like block explorers, these kind of entities need the state. So it's it's very much not a given that we can just get away with letting the state go to like multiple terabytes, right? But I'm just saying, at least it's worth a consideration because CKVM really does change the game quite a bit. But my feeling is probably we'll end up having to do something with like state expiry, but we really need to like ramp up here and like have a proper strategy so we don't just do these like one-time fixes. And they just don't scale, right? You can only keep making state growth more expensive up to some point. At some point, you're just pricing people out. But yeah, so I agree overall. So I always have trouble pronouncing this. Amizian, by the way, can you remind me how to exactly pronounce this?
No worries. It is Amizian. Yeah, I have just one comment I already shared in the chat related to 7904. So like the general pricing, I think in general is good. So we are in favor, but like in the current state with the current numbers, for me it doesn't work. For example, we have some opcodes, like even compute opcodes like mulmod that go from 8 to 3, and it will have an impact on the worst cases. So it needs, as you said, as Maria said, and you said, it needs a lot of benchmarking. Yeah, so this way, I think we can find good numbers that work for each client. I was just wondering, how do we plan to do like this work in preparation of 704? Do we plan to do it like the same way as Mod XP, for example, try to be sure that we are handling all the worst cases across all the clients? Then we are sure that, we are setting the right numbers, even for higher gas limits.
Yeah, I mean, there maybe
I would say,
Maria, you can say something.
Yeah. So I would say there the current strategy. So we are doing this in 2 steps. So first we do initial benchmarks that are trying to accurately measure what the execution time for each opcode is. And this takes into consideration for opcodes where their performance depends on the inputs. We need to take that into consideration as well. So we can estimate how much, for instance, for the exponential, the cost scales with the input, and so we also need to benchmark that accurately and build that model. And the general design is similar to what Jacek did, and this is the first step. So this will give us a first set of pricings, and then with this we go and we do the benchmarks, the gas benchmarks. Sorry, that we are already that are similar to the ModX work. So again, 2 steps. So we first do Jacek style benchmarks to get the first numbers, and then we test them against worst case blocks to make sure that we are not introducing new worst cases. Marcin, do you want to add something to that?
Yes, in the meantime, we have Geth and Nethermind, which implemented this EIP in the current form. And we don't have results yet, but we will have in days. So we'll have a first iteration where we would be able to compare the current state of the clients with the same clients, but with repricing EIP. And yeah, we'll compare the results and we'll see which opcodes are too slow, which are fine, and generally we'll take a look at the results and then plan the next steps depending what we'll see there.
Luis, do you want to add something?
Yeah, wanted to add something there. Regarding the general repricing EIP, I wonder if should not be better to push the gas limit further and make the clients optimize and force the clients to optimize before making any rush decisions on the prices overall, because that might like come down. The current performance might actually increase. Sorry, the performance might increase with the gas limit increase, and so we will be maybe in the better place going forward to really do a final revamp of all the pricings in terms of compute, mainly compute that I'm more worried about. As Mazian pointed out, I was even looking at the difference between ads and mods, and having the same cost for both doesn't seem very realistic to me, because like the algorithms differences are big, and the mods, the division is much more complex than addition. But yeah, I think that's my opinion. We maybe after increasing the gas limit to some point, then revisiting an overall pricing.
So
just an idea.
yeah, one quick comment on this from my side, because in principle, like I do agree, and like I think we will continue to push on this all the way until the Amsterdam fork anyway, which I mean, still going to be the next 9 months or so. So I think there will be. I'm personally really hopeful we can get to 100 million, say, before Amsterdam. What makes me very excited though about repricings is that it is really the best way to get away from always having to focus on these like specific worst cases, which are usually actually quite fringe use cases, right? Like with Modex, we had to focus on what happens if an attacker spams an entire block full of Modex. Obviously, no one actually does that as normal use cases, right? It's only a fringe attack case, and often it's like these relatively rarely used precompiles that then draw in all of the engineering focus. When with repricings, we can just say, okay, look, maybe they're not yet fully optimized engineering wise, but we just don't care. We make them more expensive. Then that way they can't be a weakness, they can't be an attack scenario. And that allows us to focus much more on optimizing the actual hot paths, right? I'd much rather have a conversation of percentage-wise, where is most of the time spent in the EVM, and let's optimize those operations. Let's see if we can squeeze out more efficiency there, make those cheaper, rather than always having to focus on these like actually pretty rarely used cases that only improve these theoretical scenarios, but don't actually improve real world use cases. So I personally am very much looking forward to being able to get away from this engineering focus that having to always focus on what happens to be the current worst cases. Anyway, Ben?
Yeah, just picking up on your point about, add is a lot less complicated than divide, for instance. I think that's where the rebasing or milli gas come from. So in compared to every other opcode, they're probably one. But then if you want to separate them, then you might say add is actually 0.1 gas and divide is like 0.5 gas. But without rebasing, either increasing the gas of everything up or having fractional gas, then I think they potentially average out at one gas. But there are proposals to get more precision there.
Right. So I think we are already over time. Is there any last minute comments, or should we wrap up?
Maybe just from my side, because of OCODEF tomorrow, we have 40 EIPs. It will be a big mess to find structure to get through all of this anyway, or like start the conversation in a productive way. So if either coming out of this repricing breakout, specifically around these repricing EIPs, or maybe even in general, you have some thoughts, some way that you think can help structure tomorrow's conversation, do feel free, please, to reach out to me. Any help appreciated.
Thank you, Ansgar. Okay, and with that, we'll wrap up. If you have any further comments or things you want to discuss, I'll point to the Discord channel. I think it's called EVM Pricing. And yeah, and we'll speak soon. Thank you so much for attending.
Thank you.
Thank you.
Thanks all.
Thanks, everyone.
Thank you. Bye bye.
Thank you. Bye.